Okay. All right, so sum and difference formula. Okay. So again, sum and difference or addition and subtraction, because those are the same words, okay, is a way for you to find the measure of an angle that is not on your unit circle, but its sum or differences. Okay, so for example, if I was to give you like 75 degrees and I was to ask you to find either the sine, the cosine, or the tangent of 75 degrees without a calculator or an exact answer, you wouldn't be able to do it, right? 75 is not on your unit circle. But if you break it down into a sum or a difference, like 30 plus 45, those are both angles that are on my unit circle. And so the pattern is what's on this slide. Again, another Corona perk, normally you wouldn't get these, and you'd have to memorize them, okay? But, so my advice, and I will continue to pretend as though we're memorizing them, is to learn the patterns because it will be faster than having to look at your reference sheet. The pattern for sine is sine, cosine, cosine, sine, okay? And the sign, positive, negative sign for sine, matches my original. So if this is a plus, and I want to find the sum of those two, I want to find the sine of that, I would do sine of 35, cosine 45, plus cosine 30, sine 45. And then I will actually find the value at sine of 30, cosine of 45, cosine of 30, sine of 45, and then I will simplify that expression, which you're going to see in a minute. If it was a minus in between, if it ended up being like 45 minus 30, then I would do, like, what could I do? 105, I don't know, two numbers anyways, that when you subtract them, they give that angle, then you match the subtraction for sine. For cosine, yeah.
Why are they in different orders for the multiplication? Like,
It doesn't matter. Yeah, no, it doesn't matter. So the Christian just asked, like, why that order? And it really doesn't matter. You can do sine 30, cosine 45, and then sine 45, cosine 30. It doesn't matter which way you memorize that. You just have to do one and the other. Then cosine, the pattern is cosine, cosine, sine, sine. So the actual trig functions stay the same. Cosine, cosine, and then sine, sine. And the difference with the sign, positive or negative, in cosine is that it's the opposite. So if I am finding the sum of two angles, then when I go to use the equation, I actually change it to minus. So if I was to find the cosine of 75, it would be, again, split to 30 plus 45. And for cosine, I would do cosine 30, cosine 45, and I change this to minus, sine 30, sine 45. So sine is sine, cosine, cosine, sine. Positive, negative stays the same. Cosine is cosine, cosine, sine, sine. Positive, negative changes. And then tangent is, again, you could do sum or difference. You add in the top or subtract in the top, and then you do 1 minus the product in the bottom. The only time the order matters, obviously, on the subtraction is on the subtraction. So if it's tangent of 30 plus 45, it'd be tangent of 30 plus tangent of 45 over 1 minus tangent of 30 times tangent of 45. So the plus goes in the top, and then the opposite sign goes in the bottom. If it was tan of 45 minus 30, then I would end up with a minus in the top and a plus in the bottom. All right, here's the application. So it says find the exact value. Exact means I do not want a decimal. You have to use your unit circle coordinate points. Find the exact value of each expression, cosine 120 and 45. So this time they already gave it to you broken down. So because it's cosine, cosine, sine, sine. So cosine 120, cosine 45. The sign, positive, negative sign changes, and then it's sine 120, sine 45. Now I need my unit circle. So 120 is the first angle after 90, and the coordinate point there is negative 1/2 and root 3 over 2. My cosine is root 3 over 2. The cosine at 45 is root 2 over 2 and root 2 over 2. Cosine is root 2 over 2. The sine, wait, I wrote that wrong. I said it right. I think I wrote it wrong. Yeah, this should be negative 1/2. Sorry. Cosine of 120 is negative 1/2. Sine of 120 is root 3 over 2. And sine of 45 is root 2 over 2. Now I simplify. So on the left, I'd multiply negative 1/2 by negative root 2 over 2, and I get negative root 2 over 4. On the right, square root 3 and square root 2 becomes square root 6. 2 and 2, 4. I can take it another step by combining them because they have the same denominator. And then, I'm checking Cosine. I forget if it pulls out that fraction or not. Sometimes things pull out the 1/4 at the front, so I just want to make sure. So if it was an open-ended question, that would be good enough to be your answer. I'm double checking Cosine right now because I forget. Yeah, Cosine pulls it out. So it looks like this, 1/4. And then negative square root 2 minus root 6. That's how Cosine does it. Let me check how your test is. Yeah, Christian, go ahead.
If we can break down the square root, we have to or not?
If you can break down this, yes. Yeah. He asked if you can break down the square root, do you have to? Your test has it in the format like this. Takes out the square root of 2. And it makes it negative 1 minus root 3 all over 4. So this, the questions that are multiple choice on your test look like that. It takes the root 2 out.
Why?
It's just the way that it simplifies it.
Oh, you pulled the root.
Standardized tests would pull out the root 2.
Like
Like a GCF, yep. Yeah. Sure. So Cosine. And I actually think Cosine will take this too. I'll let somebody be a guinea pig before we leave. I think Cosine will take that negative root 6 minus root 6. Negative root 2 minus root 6 over 4. But your test is going to be written, that question, multiple choice, so it'll be written like the way that I circled it. I boxed it in. All right, so that was in degrees. Obviously, you'll also see it in radians. So I've got sine of 7 pi over 3 minus pi over 3. This becomes sine, cosine, cosine, sine. So sine of 7 pi over 3, cosine pi over 3. The positive or negative sign matches with sine, so it stays minus. And then cosine 7 pi over 3 and cosine pi over 3. Now, 7 pi over 3 is not on my unit circle, but there's a coterminal that is. So this would be 2 1/3 pi, which goes all the way around the circle once and stops at 1/3, which is 1/2 and root 3 over 2. And then pi over 3 is the same coordinate point. So I'm using the same coordinate point for both. The sine is root 3 over 2. The cosine is 1/2. The cosine is 1/2. The sine is root 3 over 2. I end up with root 3 over 4 minus root 3 over 4, which is 0. Yeah.
Why did you put the negative, not with the negative pi over 3?
Because this is not on the angle, it's a minus, so you treat it separately. You'll almost never see a negative. It's possible, but you don't need it. Usually they write it in terms of a positive angle. Yeah. So you want that to determine which of the equations you pick from the last slide. If it's a plus, you pick the plus one. If it's a minus, you pick the minus. So for sine, for SIN, the positive negative sign matches. We put a minus in between because there was a minus at the beginning. For cosine, if you look at the top one, for cosine, it's the opposite one. So this is actually an example of an angle that could have been simplified first. Like if I had actually done this, 7 pi over 3 minus pi over 3 is 6 pi over 3, which is 2 pi, and then the sine at 2 pi is the y at 0, right, which is 0. Normally they will not be able, and I'll make sure that on your test it's not able to be simplified, so just make sure you know how to do the long pattern. All right, this time it says find the exact value of sine, cosine, and tangent of the angle by using a sum or difference formula. So now you have to come up with the two numbers that either add together to give you 105 or the difference gives you 105. There is more than one way to do this, but the answer should always be the same, okay? So the first thing I do is if it ends in a 5, I know it has to have a 45. It has to involve a 45. It's the only way. So what number could I add 45 to, or what number could I subtract 45 to that would be on the unit circle that would give me 105? 60. So I can do 45 and 60. Now it's asking for all three. So we're going to work through all three on this example. I'm not going to do it again for the next one, but we'll work through it all. Nope. The question was, does it matter that order? Nope. Your order on your answer will be different. If it's multiple choice, you'll recognize that it's the same. And if it was open-ended, I'd take either one. So this would be, first, start with sine. So sine of 45, remember, sine, cosine. Keep the sign so it's positive. Cosine, sine. The coordinate point at 45 is root 2 over 2 and root 2 over 2. The coordinate point at 60 is 1/2 and root 3 over 2. So the sine at 45 is root 2 over 2. The cosine at 60 is root 3 over 2. Nope, is 1/2, sorry. 1/2. Plus the cosine at 45 is root 2 over 2. And the sine at 60 is root 3 over 2. So then I get root 2 over 4 plus root 6 over 4. Again, if I was to do this as an open-ended question, I can leave it as root 2 plus 6 over 4 like that. If it's multiple choice, which these questions will be on your test, the root 2 is going to come out, and it'd be 1 plus root 3 over 4. So those are the same thing, and on your test, that root 2 is going to come out. So just make sure you recognize that format. Actually, it goes all over it on the test, like this. It keeps it like that. Questions on sine? Okay, then it had said do cosine. So cosine is cosine, cosine, sine, sine. Cosine 45, cosine 60. We change the positive negative, so it's minus sine 45, sine 60. Cosine at 45 is root 2 over 2. Cosine at 60 is 1/2. I don't know why I keep doing that. Sine at 45 is root 2 over 2, and sine at 60 is root 3 over 2. So I get square root 2 over 4 minus square root 6 over 4, root 2 minus root 6 over 4, or take out the root 2, 1 minus root 3 all over 4. And then the last one on this side is tangent. So remember, tangent is the sum or difference in the top, and then 1 minus or plus or minus the product in the bottom.
Will it always be like where it's just the positive and the negative and the answer plus 1?
Not necessarily. Yeah. Good question. Because if it's not a root 2, it changes it. Yeah. It's only because it's 45. So this would be tangent of the first. Keep the sign the same as what we've got here. So plus tangent of the second over 1. Change the sign so it's minus tangent of the first times tangent of the second. So this is where it's important to also know your tangents, right? The tan at 45 equals 1. The tan at 60, which is your over 3, is root 3. Then I plug it in. 1 plus root 3 over 1 minus 1 times root 3. 1 plus root 3 over 1 minus root 3. Can I leave a square root in the bottom? No, we rationalize. So I multiply the top and the bottom by 1 plus root 3. Because you always want to do the opposite. That's what's going to cancel out the middle term, which is the square root. So in the numerator, I'd get 1 plus root 3 plus root 3 plus 3, or 4 plus 2 root 3. And the denominator, I'd get 1 squared minus the square root of 3 squared, 1 minus 3, which is negative 2. And then I can go a step further and simplify that. Negative 2 minus root 3. Questions on that one? So the test is not going to ask you to do all 3 for each angle. It's going to ask you to do like 1. Okay? Otherwise, it would take forever. I'm going to just set up B, but I'm not going to work all the way through it. I'll work all the way through it on the video if you need it, but hopefully we understand that pattern and we're going to do it more. Okay? So what 2 numbers could I add together or subtract to give me 285? Again, first of all, it ends in a 5, which means 45 is going to be involved in some way. 240, is 240 on my unit circle?
Yeah.
Yep. So 240 plus 45. So my sine would be sine 240 cosine 45 plus cosine 240 sine 45. My cosine would be cosine 240 cosine 45 plus sine, no, not plus, sorry, minus, because it's the opposite sign. Sine 240 cosine, holy moly, sine 240 sine 45. And then the tangent would be tan 240 plus tan 45 over 1 minus tan 240 times tan 45. Are we good? Do I need to work that all the way out, or you feel comfortable enough that I could go to the next topic? We're okay, right? All right. All right, here's the opposite. Wait for it. Wait for it. There's a lag. I think I overwhelm my computer sometimes. You can't unmute yourself. The heck? Okay, so here's the opposite. So the opposite is, it's actually expanded. You have to figure out what the pattern is. Based on that, that will tell you if you're supposed to add or subtract it. And then at the end, you'll actually fight the, actually this one just says write the expression as it. In the next step, we're going to take it to the next step. So A says cosine of 25, cosine of 15, sine of 25, sine of 15. So first of all, which of the sum and differences does cosine, cosine, sine, sine? Cosine. So I know the trig function is going to be cosine. What does that tell you to do? Does it say keep the sign in the middle or change it? Change it. So this actually becomes 25 plus 15, and that becomes cosine of 40. That is not on your unit circle. If I actually said to simplify it, when you add these or subtract these, they should end up on your unit circle. Okay? B, tangent of 2x plus tangent of x, 1 minus tangent of 2x, tangent of x. If you can't figure out that that's tangent, we got a whole nother problem. That's tangent. The only thing is, which sign do you match, the top or the bottom? Top. So it would be tangent of 2x plus x, which is tangent of 3x. Questions?
So we're not gonna have to solve those?
Not yet. You're seeing in a second. They're gonna, yeah. So this one just said write the expression as the sine or cosine of the tangent. Then we're gonna actually find it. So it'll say find the exact value of the expression. You're gonna write it as one function like we just did, and then you'll use your unit circle to find that value. So you'll go one more step. And this would be like a question on your test, not the one we just showed. All right, so find the exact value of the expression. Sine 330, cosine 30, cosine 330, sine 30. So which has the pattern sine, cosine, cosine, sine? Sine. Do I keep the positive or negative or change it? Keep it. So it would be 330 minus 30, sine of 300. So I'll go to my unit circle. I'll find 300. The coordinate point there is 1/2 and negative root 3 over 2. And the sign there is negative root 3 over 2.
Are they always gonna be angles on the unit circle?
They-
Or do you wanna
They have to be. They could be like a coterminal, I guess, but they have to be on there if you're going to take it to the next step.
So they can't just give us random angles in there and then we have to break them down another way?
Correct.
Got it.
I mean, they could, but not, yeah, like maybe next year. All right, tangent 25 plus tangent 110, 1 minus tangent 25, tangent 110. Again, we know this is tangent because it literally says it. And then we match which sign?
Or the top.
Top. So 25 plus 110 is tan 135. 135 is negative root 2 over 2 and root 2 over 2. And my tangent there is negative 1. Easy stuff, right? Especially if you have the ability to have the patterns in front of you.
I'm not going to say anything's easy anymore.
When I graded yours yesterday, I was like, dude, he said he's so ready for this. He was like, this is so easy. This is going to be so easy. All right, now we're going to apply it to triangles. So suppose that cosine of negative 3 over 5, cosine of theta is negative 3 over 5 for a quadrant 2 angle. And the cosine of beta, a different angle, is 12 over 13 for a quadrant 1 angle. Find the exact value of each of the following. So notice there's two different symbols there, right? Theta is one angle, beta is another. This is not the same triangle. So I'm going to set up two triangles this time. The first one has theta in the corner. And the cosine of that triangle is 3 over 5. So the 3 is on the bottom, the 5 is on the radius. Remember, the 5 is positive, which makes that 3 negative. What's the missing value? 4. How do I know if it's positive or negative?
Wait, quadrant 2. Oh.
It's in quadrant 2, which means?
It's going to be positive.
Positive. We moved left, but we move up. Yes? We understand? Yeah. Okay, good. Then I've got cosine beta. Beta goes in the corner. Cosine is 12 over 13. What's the missing side?
11.
Oh, Lord, it's like the
14.
most common triple.
What? 16. 10.
5, 12, 13. You guys got to know this crap. I hate COVID. All right. Now that's in what quadrant?
Is it
1, so everything stays positive.
Yes.
With me? Yes? Okay, now comes all the stuff that we're going to ask below. Cosine of theta. I just need the one triangle. I look at opposite over hypotenuse. Theta is the one on the left, the purple one. It would be 4 over 5. Sine of beta. Now I'm looking at the blue triangle, the one on the right. Opposite over hypotenuse, 5 over 13. Now I get my sum and difference. So sine of theta plus beta, sine, cosine, cosine, sine. Sine of theta, cosine of beta, keep the positive negative, cosine of theta, sine of beta. Yep.
This might be a dumb question, but why can't you add what
Oh, it's not the same. So like if you look back at like, the value doesn't work the same. You'll see, like if you actually did it and then you actually work it out this way, it's not the same. Yeah, good question. Because it's not the angles, you're not adding the angles.
Yeah.
Before we were adding the angles, that's different. Now we're adding values. We don't know the angles.
Got it.
Yeah. Okay, so sine of theta is 4/5. Cosine of beta is 12/13. Cosine of theta, negative 3/5. Sine of beta is 5/13. Simplify, 48 over 65 plus a negative 15 over 65, and I get 33 over 65. Now cosine of theta plus beta, cosine is cosine, cosine, sine, sine. So cosine of theta, cosine of beta, minus, we change the sign for cosine, sine of theta, sine of beta. Cosine of theta is negative 3/5. Cosine of beta is 12/13. Those are the ones they gave me at the beginning. Sine of theta, 4/5. Sine of beta, 5/13. So I get negative 36 over 65 minus 20 over 65. negative 56 over 65.
Miss Chris, just when you said which one, like how did you know the 3 and the 5, which one was negative?
It's in the location, so it gives you the quadrant. Think quadrant 2 is on the left. We go left, but we go up. So the x is negative, but the y is positive. Questions on that one? So you're going to see both kinds of questions on your test. The ones that have the angles and the ones that have the triangles. And then we bind together the verifying with our sum and difference. So this says prove the identity. On your test it would just say simplify the expression. Okay? I get sine of pi over 2 minus theta equals cosine. And actually it wouldn't be this question because you could do it 2 different ways. It will be different. This is a cofunction. Yes? Hopefully we know this, right? This was on our reference sheet. I said every time you see the pi over 2 it's a cofunction, right? Yeah. That we already know is true. So let's break it down in its sum or difference. If I did sine of pi over 2 cosine of x, keep the sign in between, so minus cosine pi over 2 sine of x. Now we know nothing about x, but we do know what's happening at pi over 2, right? Pi over 2, 0, 1. The sine there is 1. The cosine there is 0. Cosine of x minus 0 is cosine of x. So everything, sum and difference, when we get to double and half angle, which is like the next section, all of this stuff overlaps. It's all still true. So normally you'd get a question like that. You actually like have to work it out step by step, but I have to have your test graded in 2 days next week, so that's not happening. You're going to get something that's not an identity, but you'll expand it using your sum and difference to simplify it. Questions on that one? Okay. This one combines sum and difference with solving. So it says find all the solutions of the equation in the interval of, and this should be 0 to 2 pi with a parentheses on the 2 pi. Sine x plus pi minus sine of x minus 1 equals 0. Here's my sum and difference part, right? So I break that apart. Sine of x, cosine of pi. Positive, negative matches, so it stays positive. Cosine of x, sine of pi. Minus sine of x plus 1 equals 0. Now pi on the left, negative 1, 0. Sine stays, or sine of x would stay sine of x, because I don't know anything about x. But the cosine there is negative 1. The sine there is 0. Negative sine of x, this is gone, minus sine of x plus 1 equals 0. And now I'm just solving my trig equation. This would be negative 2 sine of x plus 1 equals 0. Subtract the 1, divide by negative 2, and I get sine of x equals 1/2. So on my true unit circle, because it says 0 to 2 pi, where is sine positive 1/2? Pi over 6?
And third.
Second, right, because it's sine. Good. So your test almost feels heavy, sum and difference, because it pulls that back into the identities.
Is it going to be majority, like 5.4?
Not majority, but like it's not a 1/4 split, I would say. Because 5-1 and 5-2 I kind of have to blend together. So it's like 5-1, 5-2, 5-3, and 5-4 is really kind of what it is. But you're going to see that part of 5-1 come back into this stuff. That part 5-2. Because that's really just 5-2 solving. Questions? Okay, if you are at home, turn your cameras on, come back to Zoom, and if you are in front of me, close your iPad.